For this lesson, we're going to look at the creation of a numeric magic square using the Siamese method. If you'd like to follow along, please get out a piece of paper and pause this while you do. We're going to start out with a 3x3 box in the center, but we're going to surround it with 8 other 3x3 boxes. Each 3x3 set of boxes is an exact duplicate of itself. So as you can see from this image, every one of the boxes has exactly what it would have if it were in the same place in the other 3x3 grid. To begin our magic square, we start by putting a 1 on the top row in the center box. Now this method uses 2 moves, a diagonal move or a down move. In this case, we're going to use a diagonal move from the 1. Now that 2 put us above the 3x3 grid that we have, so if we had another 3x3 grid above it, that 2 would be where the I is. The I for our grid would be in the bottom row all the way to the right, so that's where we're going to move the 2. And here you can see the 2 placed in the proper position in our 3x3, and it's now time to make another diagonal move. Again, this move puts us outside of our 3x3 grid, so using the translation that we learned before, we will now move the 3 to its proper position in our 3x3 grid. Here we have the 3 in the proper position, but trying to do the next diagonal move is a problem because there already is a number where we want to move. Now, if you're familiar with magic squares, you know that 2 numbers cannot occupy the same space. And if you remember, I said that we have 2 types of moves that we can do, a move diagonally or a move down. Because of the blocked square, in this case, we are going to move down, so we put the 4 underneath the 3. Then we can see that we have an open space and we can go back to our original movement. Now we have 2 open squares in a diagonal fashion, so the 5 and the 6 are very easy to place. Looking at our magic square, if we do a diagonal move, do you know why the 7 will become an issue? The position of the 7 puts it in conflict with the 4. So instead of moving diagonally, we're now going to move down and put the 7 beneath the 6. This will bring us to another diagonal move and a translate for the 8. The 8 is now outside of our 3x3 grid, so we have to translate it. This brings up one more diagonal move for the 9, which will also have to be translated. Here we have the 9 from the diagonal move. Once translated, the 9 goes into the middle of the bottom row, which completes our magic square. But we're not done yet. A magic square has to have the same total for each column, each row, and each diagonal. So we need to proof our magic square to make sure that we got it right. And you can see that every column and diagonal and row comes up to 15, which is the sum of 1 to 9 divided by 3 because it was a 3x3 grid. Now let's try a 5x5 grid. So we're going to start our 5x5 exactly the same way we did our 3x3. Top row, dead center, we put a 1. course, that moves the 2 to there, which translates down to here. Diagonal move for the 3 and the 4. Another diagonal move for the 5. We have our first block, so we move down 1 to put the 6, then the 7, 8, 9 goes there, which translates out to here. 10 goes here. Again, we're blocked this time by the 6, so our 11 goes here, then 12, 13, 14, 15, and there's our 16. But our 16 would be blocked because it goes where the 11 goes. So instead of putting it up there, we go down 1 and put our 16 here. That moves our 17 up diagonally, which translates it over to the other side. Our 18 goes up. Now our 18 has a spot right here. 19 goes up diagonally. 20 goes up diagonally, but the 21 cannot because of the 16. So 21 goes here. 22 goes here. 23 translates over to here. 24, 25 would go there, so the 25 goes here. So if we take a look and get rid of all of the extraneous numbers around, that's our magic grid. Now we need to proof it, so we're going to take our numbers, copy them. I have another sheet set up for that. We paste these numbers into here, and we see that our columns, our rows, and our diagonals all add up to 65. So there we have a completed magic square of a 5x5 grid. You will find that this Siamese method works on all odd grids. So 3, 5, 7, 9 will all work using this method.